Hi, I'm Amir Hossein Mirzabozorg, and in this video, I want to talk about Comprehensive Abacus Package Chapter 9, Example 2, Bolt Connection Simulation. How to ask your video-related questions. Don't hesitate to ask any questions you might have about the explanations presented in this video using the comments below. We will try to answer all questions regarding the video details in the comments below. New Abacus users who want to develop their modeling skills faster in their projects can request user-oriented online and offline services. Subsequently, we offer step-by-step guidance, tutoring, and consultancy regarding their problems. The online service includes online sessions, and the offline service includes creating special tutorials. In addition, a combination of the two can be requested. This is the table of content for second example of Chapter 9. Okay. Introduction, the primary solution for solving nonlinear static and quasi-static problems. The static general step is the primary solution for performing nonlinear static and quasi-static simulations. Also in the previous chapters, for example, in chapter 6, when I simulated tensile test, I used a static general step, okay, for doing nonlinear analysis. For tensile test, we had two nonlinearities. One, the plastic behavior, second, nonlinear geometry, okay, which is related to large deformations, and a static general step was successful in solving all of these, okay. Using the static general step, all of the sources of nonlinearity can be included in the simulation. A wide range of nonlinear simulations can be performed by using this step, but convergence issues may arise in some simulations, and the Abacus standard solver will fail to complete the simulation. One of the most effective solutions for resolving these convergence issues is using dynamic steps instead of static general. What are the dynamic steps? Dynamic implicit step and dynamic explicit step. Here I have mentioned two cases, mechanical problems and coupled thermomechanical problems. For mechanical problems, the primary solution is the static general step, and its solver is Abacus standard. And for coupled thermomechanical problems, the primary solution is coupled temp displacement step, and also its solver is Abacus standard. And the secondary solution for mechanical problems are dynamic explicit and dynamic implicit steps. The solver of dynamic explicit is Abacus explicit, and the solver of dynamic implicit is Abacus standard. So the solver of dynamic implicit step and the static general step are the same. And the secondary solution for coupled thermomechanical problems is dynamic temp disp explicit step. The solver of this step is Abacus explicit. In this course, we don't cover this step. Maybe in the advanced Abacus course, I will solve several problems using this step. For example, to simulate the hot rolling, we must use dynamic temp disp explicit step, because this simulation is highly nonlinear, and in this simulation we have contact and large deformations, and also material changes with temperature, and it increases the degree of nonlinearity of the simulation. And that's it. Please notice that here I have set secondary solution. Hello, Mr. Qasemi. Here I have mentioned secondary solution. Okay, it means that first we must try using these steps, and then if we face convergence issues and we cannot solve them, so we must switch to these steps. Okay, they are alternatives. And some other issues that force us to use secondary solutions. But if we don't want to do trial and error, we can use another procedure. We can use this formula. The average speed of the rigid part or rigid punch must be less than 1% of wave speed. And the average speed of the rigid body is equal to the distance of its displacement divided by time period. Okay, and also we know the value of CD. For example, here I have calculated them. For that example, okay, for that example, the aluminum plate, CD is equal to this value and displacement of the punch is 0.2 meter. So displacement of the punch divided by T must be less than 1% of CD. So the time period of the step must be greater than 0.004 seconds. Okay, so the minimum allowable time period is 0.004 seconds or 4 milliseconds. But if I want to be conservative, I multiply it by a factor of 2.5, so the time period will be 10 milliseconds. For accuracy, the calculated time period is multiplied by a factor greater than 1 to increase the time period and make the simulation more quasi-static. And here I have entered 0.01 for the time period of the step. And this is the force displacement curves for all four simulations. You can see that the light brown one is the static general one, and also the pink. The pink one is obtained using mass scale, and the dark brown one is calculated using loading rate, and the blue one is obtained using the dynamic implicit step. Here you cannot see the light brown one because it is covered with the blue curve. Okay, it is covered with the blue curve, and they are almost the same. Okay, they are almost the same. Because of this, you cannot see it here. Okay, that's it. And about conclusions, the force displacement curves of the dynamic implicit and static general steps are very similar because they have the same solver. When you use the dynamic implicit step to solve a quasi-static problem, the solution will be so close to the solution of the static general step. The results obtained by Abacus explicit and Abacus standard solvers are similar. This means that the solutions are quasi-static and accurate. Okay, now I want to solve second example of chapter 9. It is related to bolt connections. Okay, it's related to bolts connections, and this is our reference paper. Let me show you this paper. This paper is very good, and one of your exercises for the next session is to read it completely. Okay, you must read it completely. I will mention some important sections of it, okay, but you must read it completely. And as you can see, it is very technical, and its concentration is on abacus. Such papers are very good. Such papers that are concentrated on abacus modeling or FE modeling, they are very useful and very valuable papers, but finding them is very hard, okay? And one of my students sent this paper to me several years ago, maybe 4 years ago, 4 or 3 years ago, and I I archive such good papers, then I can use them in my videos and courses and or tutoring sessions. And yes, you must read it completely. Okay, I go back to the slides. As I mentioned before, this is our problem. Okay, it is a lap joint, and we have two bolts. They are preloaded, and this face is fixed, and this face will move, and we apply displacement control loading to this face, and you can see the mesh, and I will generate this model according to the points written here. Okay, that's it. So this is top view. Okay, this is the plate hole, and this is the bolt shank. I told you they have difference. This radius is 10, and this radius is, I think it was 12, yeah? 12. Yeah, 12? Is it 12 or 11? Okay, I think it was 12. And, let me, to be sure. Yes, 12. And I want to mesh them, okay? What I told you 16 elements, 16 nodes, okay? Is it okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. No, no. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? And each of them must be exactly in front of the other. What color I should use? This one. See? This is very important for contact analysis. If you don't use this kind of mesh, if you use Abaqus standard solver, you will have convergence issues, okay? You will have convergence issues. And if you use Abaqus explicit solver, you don't have convergence issues, but the contact results will not be good, okay? Because a snagging problem happens, okay? And this is very important. I found this issue last year when I had a PhD student. She was from Amir Kabir University, and her major was geotechnic, okay, PhD in the geotechnic engineering. And I told her to change the solver to explicit. Then she didn't face any convergence issue, but also the contact results was not the contact results were not reliable, okay? And we found finally that even for explicit analysis, this mesh design must be used, okay? This is very important. Actually, and if you see here, I create another viewport. Oh, I open job 2. Okay, I open job 2, and this is the end of job 2. Okay, and here we have the beginning of job 3. Please look at the results. They are the same. Okay, they are the same because we have imported the results, and it is running, and as you can see also it is deformed. And for example, in a step 3 of job 1 times 0.16. You can see that the results are similar. Okay. Also, the contours are similar. Here. Yes, please ask your question. Yes, what is your question? Don't you have any question? Uh-huh. Um, and if I compare the results of force displacement, this is force. If you see, they are close to each other. Okay, they are close to each other, and here I want to talk about
Sorry, can you hear me now?
Yes, I can.
I talked several times, but I thought that it was something wrong with
Yes,
my
please ask your
microphone.
question again.
Yeah, I just asked how many sessions have they left to the end of the tutorial?
I don't know because I suppose that at the end of this session uh, we will reach the end of chapter 10. Okay, but we didn't reach it. Even and yes, because I don't know why we are slower than what I'm thinking. Okay, I think one of the causes is because I want to tell you everything, and
Exactly. I think you explain in depth every point, and you
yes,
put although there are not very people in the sessions to ask you the question, but you explain everything. So
yes,
thank you. And I don't know why the other guys don't attend in the class. They missed valuable
yes.
points.
It's
Maybe they can ask their questions, and you are ready to answer. But
yes. Also, if they ask, if more people attend to the class, the speed even decreases more. And yes, but because uh, I taught these concepts previously, but not with these points. I mean, this course is the most complete thing that I can present. Okay, I can teach, and because of this, yes, the speed is slower than what I think. And here, let me tell you about okay, here this is the these are the difference between the explicit simulation and a standard simulation. Okay, you can see that they are similar to each other, but sometimes um, uh, uh, the difference increases. And here I want to talk about what are the sources of difference in the obtained results. Is there any mistake in the settings of one of the models? Is this difference reasonable, and does it make any problem when convergence issues arise in applying the main laws using Abaqus standard solver and the only choice is using the Abaqus explicit solver? Please tell me your answers. Please think about them right now. This is the difference, okay? You can see both curves, okay? And please tell me your questions, your answers. First, what are the sources of difference in the obtained results? Do you have any idea? Don't you have?
Actually, I'm thinking.
Okay, think, no problem. Think, because thinking is very important. Give me your answers for all of these questions.
Okay.
Yes, think about them. How to purchase packages or individual chapters. Each of the packages and individual chapters includes CAE, JNL, and IMP files, step-by-step tutorials with detailed explanations and investigation of the results, and slides and reference papers and standards. Packages specifications and payment details are provided in the video description. Also, you can pay the cost of the packages in 2, 3, or 4 installments according to your budget or income. In the future, updates will be provided for free for everybody who purchases each chapter or each package. The cost of each chapter or package will increase after each update for new buyers, but those who purchase the package would have endless access to all the upcoming updates. This will make the content up to date for new needs and new problems which must be solved via FE simulation. You can contact us using Telegram or WhatsApp, or you can send email to us. We can have one-on-one tutoring on the AnyDesk WhatsApp, and we can make special tutorials to your order. We can conduct high-quality simulations for your thesis, exercises, and industrial projects. And we offer support in writing the modeling and result discussion part of your thesis, and we have consulting services for MSc, PhD positions, or job interviews, and we can help you to prepare the presentation of your simulation works. Now I want to suggest you several related videos of our YouTube channel. Thank you so much for watching this video. Have a good time. Goodbye.